Okay, I want to start off and I want to talk about what electricity is. I really want to talk about making electricity, but before I do that, I need to talk about what electricity is. So let's start very simple. Let's start with a person. And with a person, let's say we look at a small part of a person, and we know that they're made of atoms, lots and lots of atoms. And if we take one single atom and look at it, what we see is that there is a small positive nucleus, and then there's negative electrons around the outside, depending on how many protons are in the nucleus. So these things, these positives and negatives, the protons and the electrons, these are electric charges. So does that mean that we humans are electricity because we're made up of electric charges? No, and here's the reason why. My definition for electricity is this: moving one type of charge relative to the other. So if you take an atom and you move it, that's not electricity because you're moving both the positives and the negatives. If you could take an atom and move just the negatives or move just the positives, then you would have electricity because one is moving and the other one isn't. Or actually they could both be moving. One could be moving one way, one could be moving the other. But that's ahead of me. So let's do something easy. Let's start with a conductor. Let's say we've got a wire and it's only, let's say, 1 atom thick, so that way I can draw it really fast. And it's got a positive nucleus, and then each of these atoms has a certain number of electrons. So I'll just stick on a few minuses here. And if you can take those electrons and if you can move them one way, the atoms stay put. So if you take the electrons, which are mobile, and you move them left or right, in this case I drew an arrow to the right, then you get electricity. You get electricity because you're moving one type of charge, that's the negatives, relative to the other, that's the positives. The positives stay put because they're locked in place. The whole atom is locked in place. So that is how you can make electricity. Now, just as a side note, is it possible to ever move the positives? Sure, that is possible. Inside of like a car battery, and this is a terrible drawing, but inside of a car battery, you've got chemicals, and what's happening is the battery is filled with a liquid. And in a liquid, both things can move. So in a liquid battery, what happens is the negatives can go one way, and the positives can go the other way. So it is possible to have the positives move if you have a liquid or even a plasma or a gas, I suppose. So don't get the idea that all electricity is just electrons moving. It can be protons too if you've got, some kind of a fluid. All right, so how do we make our electricity now? Well, there's a bunch of different ways to make electricity, and the way that we do it now, our main method is to use magnetism. We use magnetism to move, or to make electricity, to move charge, to move electrons through wires. So here's a simple, a terrible simple drawing of a power plant. Let's say we got a big pile of coal. Maybe you've seen one of these sketches before. And we take that coal and we burn it, and we use that heat to boil water. And that boiling water makes steam, and that steam we force it through pipes, and then we make it spin this big fan called a turbine, and then we cool it off and send it back to be reheated again. And that turbine is hooked to a generator. So inside that generator, what's going on is you've got a coil of wire, and you've got a bunch of electromagnets or magnets. And so when you move the wire or the magnet, either one actually, what happens is the electrons and the atoms of the wire feel a force, and then the electrons move. So then from that we get electricity that we send through power poles off to our homes. Okay? So the one way that we make our electricity now mostly is magnetism. Although, doesn't that seem kind of wasteful? Look at all the stuff we do before you get to the actual generating of the electricity. Before we generate the electricity, we have to get the coal, we got to dig it up, we got to move it to the power plant, we've got to burn it, we've got to manage the steam, we've got to rig up the turbine, we've got to spin the generator thing. It just seems kind of wasteful, all those steps, because every time you add a step, you lose efficiency, right? So here we are, we're at the end. The real reason why I wanted to make this video is to talk about the other ways to make electricity. Now, in my class in Moodle, there is a link to this web page. Let me show you where it is. It's wisc-online.com. Lots of good stuff there, wisconline.com. Anyway, inside their website there is this applet, and you can snoop around and you can see 6 different ways to make electricity. So right here, magnetism, if you click on it, it zooms in and it talks about moving a magnet in a coil of wire and you get electricity. I'm not going to read everything that's here, but you should visit this site and snoop through at least once or twice. But other ways to make electricity. This one right here, light. You guys have heard of solar power. When light comes in, you can make electrons jump from one kind of material to another. Okay, so the nice thing about that is there's only one step. Light hits the stuff and the current flows. Pretty easy. Seems pretty efficient. We're working on making it more efficient. What else? We've got heat. How can you use heat to make electricity? Well, it's a lot like light because you've got 2 different materials. In this case, there's copper and zinc. You put them in contact with each other and you heat them up. Well, one of them loses electrons easier than the other, so the electrons jump from one metal to the other, and that makes a current going through the wire. So you can use heat to make electricity. Another one, friction. You've seen this before. You're unwrapping something with plastic and a little bit of plastic falls and it sticks to you. That's because it's got electricity, a static charge is what we call it. Let's see, another one, chemistry. We talked about chemical car batteries. You've got different kinds of metal in this case, in this one, and you've got water and hydrochloric acid. One of these metals loses electrons easier than the other, so you get a current flowing. Let's see here. Pressure. This one is kind of weird. If you take a crystal and you hit it or deform it, the electrons will all rush to one side, and that is current. And that's how record players work. Do you guys know what record players are? Anyway, also sonar, like how Navy boats find other, like submarines and stuff. That's how that is generated. Anyway, so I think I've covered all these pretty quickly, but this website I highly recommend that you give it a visit before you take this mastery quiz.